Yes, so hi everyone. In the last class, we discussed about coordinate system, right? In this class, I'm going to talk about differential length and differential area and the differential volume for all three coordinate systems. Already we have done the coordinate system and we got to see that the parameter in sequence for Cartesian coordinate system was x by g, right? And r theta phi and rho phi g, right? This was for cylindrical coordinate system, this was for spherical, and this was for Cartesian coordinate system, right? So now we are going to see the differential length, okay, differential element, okay, which are present in case of all the coordinate systems, okay. So differential length, or you can say differential element as well, right? Just write here that differential element. Okay. So what are the differential length we are going to talk about? We will talk about differential length. We will talk about differential surface, right? Or area, you can say. And we will talk about volume, differential volume. Okay. If somewhere triple integral is present, then you need to consider volume of that, right? So differential elements. So you have to add here differential length, differential area, and the differential volume. In case of Cartesian coordinate system, Cartesian coordinate system, what I'm supposed to do here is that we will take we will take our, this is one axis, this is y-axis, and this is going to be your x-axis, right? Okay. And now here we will draw one cube, right? A small cube, you can say, which will capture that point, right? This is a small cube. Let me erase, right? So you have to carefully observe the way I'm drawing these things, right? And the way I will be talking about differential length. And again here one, square you can make. Right. So this is going to be our cube, right? Okay. Now what we can do here is that we can do here, we can take the projection of these cubes on these axes, right? So this is our y-axis, this is x, and this is z-axis, right? So take the projection of this, right? So it is the entire y-axis, and we are considering the projection of this cube. This object is here, that is going to be your d by, right? D by, you can say d by, okay? And the projection of this is going to be on the z-axis, that is going to be z, dz, because we are considering the small element, right? So differential element means what? The small element. Differential, right? Differential means what? The small element we are considering, that is small, some part of this z-axis, right? And here it can be taken as this is dx, right? So the differential length can be written as for dl, for Cartesian coordinate system, okay, because the length is also going to be vector here, right? Suppose we want to go from this point to this point, okay, and here to here. So this is A and this is B, and we want to go from A to B, so we will have to go from A, in the y direction, then we will have to go in the x direction, and then we will have to go for z direction. Here you are moving in the x direction, right? In the negative, okay, so you have to see here the magnitude is going to be positive, but the direction is going to be negative, right? So basically we will consider the magnitude only and forget about this direction and all. We want to go from A to B, right? So we can write here dl, okay, so we are covering you can say dx, okay, in the x direction, dx length, okay, ax cap, right, plus d by a by cap plus dz az cap, right? So this is going to be our differential length, right? Differential length for the Cartesian coordinate system. Remember always differential length for Cartesian coordinate system, right? Remember always this, right? So you have got dx in the direction of x, dy, okay, dz. So these are the differential length, right, corresponding to x, y, and z, okay, right. In case of if I talk about differential area, right, differential area, what is differential area? What is area first? Area is basically the product of two length, right? Product of two length, two differential length, you can say differential length, because we are talking about differential area, so we need to have the product of two length, right? So if suppose we consider this part of the cube, right, the front face, right, this, okay, so what is going to be the area of this? What is going to be the area of this, right? So this is going to be our open surface, you know, any surface has the area. So we have got two kind of a surface, one is open surface and one will be the closed surface, right? Closed surface, open surface and the closed surface, right? So what is the length here? That is dy and the dz, the product of dy and dz, and the direction is going to be in the x direction, right? Remember. So differential length will be what? The product of two length. So you have got dx in the x direction, you have got dy in the y direction, you have got dz in the z direction. So what you can do here is that you can write ds vector, right? Ds vector is gonna be for, if the normal is x ax cap, right? If the normal is ax cap or x is constant here, right? So you can say that dy and dz will be the surface area, differential surface area. Here the x is considered to be constant, right? Or fixed, you can say, or fixed. And we can also say that differential area is going to be dx times dy if az is constant, right? And differential area is going to be what? So you can see here, this is going to be the magnitude, okay, of the area, and this is going to be the direction, okay. And if that is the open surface, if you take one wire, right, and just make the circle, right, like this, so this is the open surface, right? Open surface. So the direction of this circle is going to, orientation is going to be what? You can say either you can go inside or outside, right? So the always outward normal and cap, right, is going to be the direction of this circle, right? So whenever we write the area of the circle, that is pi r square, and n cap we don't write, okay, remember. So area is basically a vector quantity, right? And here dx dy, and now we can write here that is dx times dz, and direction is going to be a by, okay. So keep these things in mind, okay. So you can take one part at a time. So let me draw here, this is x, this is y, and this is z, okay. And if we take this part of the cube, and if we take this part of the cube, okay, and if we take upper surface, that is you know, like this, okay. So now you can see the direction of this, okay, surface. This will be corresponding to ax cap, and here the z is varying and the y is varying, x is varying, right, and the y is going to be constant. So you can say that it will be outward normal here, okay. And in this case the x is varying and the y is varying, so the direction is going to be az cap, right? So always outward normal, you can say outward normal or normal only, right? Okay. So these are the differential area. And if I talk about the differential volume, if I talk about the differential volume, okay. So what is the differential volume? Differential volume means, what is volume basically? Volume means product of three lengths, right? Product of three lengths. So the dV is going to be what? Dx, dy and dz. Your volume is basically the scalar quantity, right? This guy is a scalar. Okay, it does not have any direction. Understand? So dx times dy times dz. This is what the differential element for the Cartesian coordinate system, as we have got to see. So we have got dl. You have to keep this in mind, dl. Okay, because sometimes you will be asked to find a dot dl, right, like this. So in place of this dl, right, you can keep, you can substitute these this expression, right, dx ax cap d by a by cap plus dz az cap, right? Okay, so that you will be able to compute this integral. Okay, right, and you have got the area as well, ds. Okay, that is dx dy az cap dx dz a by cap and d by dz ax cap, right? So these are the different surface area. Okay, why I'm discussing all these things, you will come to know. Okay, suppose there is a line charge kind of concept is there, line charge L, right? So you have to find the total charge on it, right? So what you will do, you will take one segment. Okay, this is DL segment, right? DL. So what you will do here is uh, uh, it has the rho L, charge density. You can say it has, you can say coulomb per meter, right? So you can multiply rho L dot DL and integrate. So you will get total charge. Okay. So this is the main application where we use these differential concepts. So this is the smaller, small element we are going to take and integrate to find the total charge, right? In this DL, there is a rho L times DL charge, understand? But if you want to find total charge distributed on this line, so what you will do, you will have to integrate. So this guy is a dq, okay? These things you have to keep this in mind, okay? Wherever we will, and if there is a plane or surface, we will consider ds, okay? And surface charge density will be given. And if you want to find total charge, so we'll come to that when we will start discussing about electrostatic. I'm just refreshing your basics, right? Okay, so this is going to be your surface area, and here you can also write your dv. Dv is going to be your dx dy and dz. Okay, dx dy dz, and your volume is basically the okay. So I hope this is clear for Cartesian coordinate system, right? Now we will talk about cylindrical coordinate system. Cylindrical coordinate system. So in case of cylindrical coordinate system, what we can do here is that again we can take this is z-axis, this is y-axis, okay. For the sake of reference, this is x-axis, right? Okay. Now what we can do here is that we can take the cube here, okay, and the cube is gonna be hanging here, right? So the cube we can keep here, right? That cube is here, okay, and this is phi, okay. So this is gonna be our R cube, complete cube, okay, which is hanging like this, okay. So from here to here, right, this is d rho, because you know that rho is this, right? So if you are extending, this is rho, okay, so this is d rho, okay, and this will be rho d phi, okay, because you know that in the direction phi, right, this is phi. So if you will if you will increase phi, okay, little, So this is d phi. D phi is what? The little part of phi. Okay, little change in phi. So this is you. After all, we are talking about length, right? And your d phi is what? Your d phi is going to be angle. How can you convert angle into length? So you will have to multiply, right? So rho times d phi, radius times angle gives what? The arc length. Okay, so this is basically the arc here, right? Okay, and dz will be same. Okay, so rho d phi dz, right? So now we can write here uh, dl is gonna be, dl can be written as d rho in the direction a rho cap plus rho d phi in the direction a phi cap dz az cap. Okay, so this is going to be the differential length in case of cylindrical coordinate system. So how many lengths are there? See, this is d rho in the rho direction. Okay, little change in rho. Okay, and rho d phi is the length again, and dz, this is arc length, right? Rho d phi, here the radius times the angle. Okay, so if I talk about surface area here, surface differential area. Okay, now the magic will start. Okay, the moment you will understand these things. So differential area means what? Differential area means you can see here, if we take this part, okay, this face, okay, on the cube. Okay, so here d rho and dz is changing, right? D rho and dz is changing. So what is constant here is, you can say, the phi. Okay, so ds vector can be written as d rho dz. So what is constant here? The phi. Phi is not varying. And ds, okay, so this is the direction, right, for the area, for that surface. Okay, and rho d phi dz, if we consider these two lengths and take the product, right, rho d phi dz, so what is constant here is that a rho. Okay, and ds can also be written as uh, rho d rho d phi. Okay, so what is constant is az cap, right? So you might have seen whenever you compute double integral, so you use this kind of thing, rho d phi, or rho d phi dz, or d rho dz, right? So whenever we will discuss vector calculus, so there we are going to use these things. Okay, or when we will talk about Dell operators, okay, uh, gradient, okay, or curl, right? Gradient, divergence, and curl we will talk about. So we are going to use this concept of differential length, right, to remember the formula as well. Okay, surface differential area for cylindrical coordinate system is going to be ds equal to d rho dz, and phi is constant, and the phi is the normal here. Okay, in case of when rho is changing and the dz is changing or z is changing, right? Okay, now we can talk about volume of that. Okay, so volume is very important. What kind of volume I'm talking about? Differential volume, right? Okay, so differential volume will be the product of three lengths. Okay, product of three differential, okay, length. Okay, so what we can do here is that this is going to be your dv. So rho, d rho, d phi, and dz. But this rho is in the expression you might have seen, this row comes with d phi, remember, but the way we read it, okay, dv equal to what? Rho d phi dz. Keep this in mind. And if you're not able to keep this in mind, it's okay. If you are able to keep this d rho d phi, and dz, just take the product of these three for the sake of volume. And if you want to find the surface area, in the question they will mention that one coordinate is fixed, or they have given the value z equal to 5 plane, right? If z equal to 5 plane is given, so the differential surface area will be rho d rho d phi. Understand? Suppose z equal to 4 plane. So what is going to be the surface area, right? So you have to ds equal to what? It will be rho d phi and az cap, because this guy is a constant. So okay, this is how we have to keep this in mind, right? Anyway, spherical coordinate system now. Spherical coordinate system. Okay, so what are the coordinate of spherical? R theta phi. Okay, r theta phi. R theta phi. Okay. So we need to again find okay. So you can say here is that just I'm directly writing now r theta phi. So you will get dl equal to dr ar cap plus r d theta a theta cap plus r sin theta d phi a phi, right? R sin theta d phi a phi. So remember all these things, okay? So there are three lengths again, dr, r d theta, because theta, if theta is having the incremental change, that is d theta. So if you want to make it length, so you will have to multiply with r. And if there is a phi, there is a variation, phi, little variation, okay? So if you want to make it length, so you will have to multiply with r sin theta d phi. Understand? Okay. So you can find the ds as well, ds vector, right? So just take the product r dr d theta. So what is going to be constant here? You can say a phi. Okay, so spherical coordinate system basically will be used in case of antenna. Antenna to analyze. Remember, there we will talk about theta and phi. Okay, theta phi angle. Our radiation intensity will depend upon these theta and phi. The polarization will depend upon theta and phi. Many more things, directivity, okay, and everything. So keep this in mind. Understand? So ds equal to r dr d theta, and ds can be written as you can multiply these two right now. So r square sine theta d theta d phi, and what is constant here is that ar. Now ds can be written as what? You can take multiplication of these two, right? So what you will get here is that, because you know that r theta phi. So if you are taking the cross product of this r cross theta, and okay, so r cross theta means phi only, okay? So just take the multiplication of this and this, okay, phi, r phi, okay? So multiply this, so what you will get here is that r sin theta dr d phi. So what is constant here? A theta, okay? So these are very, very important concepts. You have to keep this in mind. Understand? I hope this is clear for everyone. Now let us talk about this differential volume for spherical coordinate system. Okay, differential volume. What is differential volume? dV will be equal to what? R dr. Okay, so just take multiplication of all three elements. R square sine theta dr d theta d phi. Okay, so if somebody is going to ask you what is the volume of the sphere, so you can integrate this. Okay, you can integrate r square sine theta dr d theta d phi. So if someone is going to ask you find the volume of the sphere, right? What is the volume of this? Well, everyone knows, but you can directly compute. So this is dV, that is differential volume. So if you want to find V, so you will have to integrate dV. And there should be triple integral, right? R square sine theta dr d theta d phi. Okay, so you know the limits. Okay, you can say R is varying from 0 to capital R, and your theta will vary from 0 to pi, and your phi will vary from 0 to 2 pi. Okay, so what you can do here is that R square means what? R cube upon 3, and your phi will okay, will be giving you 2 pi into sine theta, means integration of sine theta means minus cos theta, right? Uh, okay, because sine theta has a differentiation cos theta. So sine theta has integration will be what? Minus cos theta, right? Minus cos theta. Yes. Let me raise this and write properly. Okay. So what you can do here is you can keep here, right? So what you will get here is that you will get 2. Okay. So as we know that 4 by 3 pi r cube, right? This is the expression, right? Expression for what? Expression for, you can say you will get 2 from this sign component. So 2 2s are 4, right? So this is the volume you have got. Okay, so as I told you that consider the differential volume and find the total volume. This is what the applications. Okay, so the integral limit is getting decided by the parameter which you have already studied. Okay, as I told you. Now let's talk about Dell operator. Okay, Dell operator is very important. Uh, Dell operator is basically a vector space function, right? It is a vector space function. It is a vector space function, right? Okay. So Del is written like this, okay, where partial derivative with respect to space variable, that is dou by dou x, ax cap, dou by dou by, okay, a by cap, and dou by dou z, az cap, right? So this del, remember this del is gonna be the Dell operator, right? Sometimes it is also known as nebula, right? So Dell operator is basically a vector differential operator. So you can also write that it is also known as, vector differential operator, right? Vector differential operator, right? Vector differential operator. Okay. Sometimes it is also called gradient operator, right? Gradient operator. Okay. So remember that this is not the vector quantity. Remember, del is not the vector quantity. Okay. So I mean that gradient operator is not the vector quantity. Remember, right? Gradient operator is not the vector. So sometimes del is also known as gradient operator, and gradient operator is not the vector quantity, right? Okay. When it is operated on the scalar, right, it makes the vector quantity, remember. Okay. So from the gradient we will also talk about directional derivative, right? So we'll try to understand the concept of directional derivative. Okay, directional derivative, what does it mean? DD in short, right? So let's talk about gradient operator, right? What is gradient operator? So gradient, okay, so gradient operator, what does it basically is that, what is the job of gradient operator? It converts, okay, it converts scalar, scalar field to the vector field, right? A scalar field to the vector field, right? Okay. What we are trying to convey here is that suppose the V is a vector quantity, I mean, and some scalar field, right? V is some scalar field, okay, function of x, y, and z. So the operator times V, okay, will be the gradient of V, okay. It is read as gradient of, okay, scalar V. This is a scalar function, okay. And what is the significance of this gradient? Significance. What is the need of this gradient operator and why we want to convert into vector field? Suppose the very well known, remember this is a notation here, this is a gradient of V, remember always. As we know that the temperature is basically the scalar quantity, right? Scalar quantity, okay. So suppose we are moving on the ground, okay. Suppose this is a ground, right? This is a ground here, right? And this is earth, right? And we're moving here, right? So the temperature at this point is something, and once we move here, some temperature is, something, right? So what we can say here is that sometimes temperature is same when you are in the earth, right? But when you go up, okay, so the temperature start differing, right? Temperature is different here, temperature is different here, temperature is different here, right? So in all the three directions, right, with respect to space coordinates, right? So if we want to capture, this variation with respect to the space variable, right? If we want, okay, if we want to capture, okay, variation of any scalar quantity, right, with respect to space variable, right? Space variable x, y, z. So then gradient comes into picture. Where the maximum temperature will be, where minimum temperature will be. All these kind of information will be stored or captured by the gradient operator. Remember. So gradient operator operates on, when gradient operator operates on, okay, when gradient operator operates on scalar function, so it gives you the vector one, it gives you vector, understand? So always keep this in mind. Suppose there is a del dot v, so we can write this as dou by dou x ax cap, right, plus dou by dou by ay cap plus dou by dou z az cap times v. You can take this p inside, this v inside here, so rate of change of this temperature, you can say, okay, v, or potential, right? Potential. So dou v by dou x ax cap, okay, dou v by dou y ay cap plus dou v by dou z az cap. So now you can see initially my v was, this guy was scalar, right? And this guy, this is a gradient operator which is operating on scalar and giving you what, the vector, right? This is a variation, right, with respect to x, y, and z, okay, of the temperature, or you can say the potential. So gradient operator captures the variation of a scalar quantity in with respect to x, y, z coordinates or space variable, right? Okay. This is very, very important concepts, right? Okay. So let me talk about this is gradient, okay, and the well-known example which we will study in case of electromagnetic. In fact, that expression will also come into picture when we talk about electric field in case of PN junction or anywhere, right? So the well-known example of well-known scalar quantity, right? Well-known scalar quantity what we study is the scalar potential, right? Scalar potential. So the relation between electric field and the scalar potential is what? The electric field is a vector quantity, right? This guy is a vector field, okay? And if we take the negative gradient of potential, right? Negative gradient of potential, okay? It is read at negative gradient of potential, okay? What is gradient is basically, the gradient is basically here the slope. Gradient means slope, right? So if somewhere the slope is there, definitely there would be the there would be some potential difference, and that is going to be giving you what? Electric field, right? So electric field is basically the negative gradient of potential. If there is a slope, so there would be some electric field, right? In case of energy band diagram also, suppose this is a band diagram for n-type semiconductor, and your Fermi level resides near the conduction band is, right? That is EC. Okay, sometimes so these are the applications we study in electronic devices as well. So that's why I always stress electromagnetics should be studied properly, right? So now there is no slope in this energy band, right? There is no slope, right? So there will not be any electric field. Electric field will be zero here. But if there is a slope in the bands, right? So electric field will not be zero. Why? Because there is a gradient. There is a gradient, okay? There is a slope, right? So how can you find the electric field then? The electric field can be found out with the help of this expression, that is the negative gradient of potentials, right? And the inner, the relation between potential and the energy, okay? uh Relation between potential and energy. What is the relation between potential and energy? So potential and energy dw by dq, okay? So just multiply q with v, you will get energy, right? These are very basic things which you must understand, okay? So gradient has physical meaning. It has great great importance in all electrical engineering or electronics subjects, right? So well known scalar quantity, as I told you, is the scalar potential, and this relation you have to keep this in mind, okay? Okay, so this is the gradient operator which operates on the scalar quantity only. It does not operate on vector quantity, remember. Okay, so in case of suppose V is the scalar 1 and gradient of V is the vector 1, right? As we have seen. So if I talk about in case of Cartesian coordinate system, so in cart, your gradient of V can be written as dou V by, just let me remove this guy again. So dou V by dou X, AX cap, right? Dou V by A by cap, dou V by dou Z. Okay, so in order to capture the information variation related to variation of potential in all the direction, I'm going to use the gradient operator, right? And gradient means the slope, simple, right? And these rate of these dou V by dou X represent rate of change or this scalar potential, right? What does it represents? Rate of change with respect to x, y, and z. Okay, with respect to x, y, and z. If I talk about in cylindrical coordinate system, so you might have observed here is that the gradient of v was in cart, that is dou v by dou x, ax cap, dou v by dou y, a by cap, right? Dou v by dou z, az cap, right? So there is what? This az, right? So you might have seen there is a differential length involved, right? dx, dy, dz. Okay. In the same manner, we can write for in case of what? In case of cylindrical coordinate system, right? In case of cylindrical coordinate system, cylindrical coordinate system. So what are the differential length here we have seen? We have seen d rho, rho d phi, okay, and dz. This is how we can keep in mind, okay. So here the gradient of v in case of in case of differential in case of cylindrical coordinate system, we can write here that is dou v by dou rho, okay, a rho cap plus there is a rho d phi, right? There is a rho d phi. So what we can do here is that 1 by rho dou v by dou phi, okay, a phi cap plus dou v by dou z, az cap. So you can see in the denominator, this is the differential length, rho d phi and dz. So this is how we can keep in mind, and whenever the scalar function is given in terms of cylindrical coordinate system, okay, so in cylindrical coordinate system, right? So if they are asking you to compute the gradient of that scalar function, what you have to go for is this expression, right? So only thing you need to keep in mind is that the differential length, okay, rho d rho, rho d phi, and dz. Now in case of spherical coordinate system, okay, coordinate system. In case of spherical coordinate system, what we can do here is that we know that what are the differential length, again we need to recall, because that is going to be helpful. Okay, differential length. So dr r d theta and r sine theta d phi. So you may be bothering here is that how this guy is coming, right? That r sine theta, why r sine theta is coming? So you know that if I write dr r d theta, because r theta phi is there, right? So this phi is coming because of that rho, right? So dr r d theta rho d phi, right? Rho d phi, okay. But this rho parameter belongs from this cylindrical coordinate system, right? So you need to convert this rho as well. So as we have seen yesterday that rho is equal to what? R sine theta. That's why we plug here, right? So this will become dr d theta and r sine theta d phi. Okay. So this is how we have to keep the gradient gradient formulas. Okay. Remember, if you are able to recall differential length, so you can write the gradient of gradient of any scalar function in spherical coordinate system can be written as gradient of v is equal to dou v by dou r a r cap plus r d theta is there. So 1 by r dou b by dou theta a theta cap, and then 1 by r sine theta dou b by dou phi a phi cap, right? So very easy to remember, right? If you're able to recall these differential length, this is the differential length I'm telling you. So in spherical case, in spherical coordinate system, this is how we write the differential, the gradient operator, right? Which operates on the scalar function. So I hope this you can keep in mind, right? Okay. So gradient magnitude basically represents what the maximum rate, space rate of scalar. Okay, maximum space rate of change of scalar in magnitude as well as the direction, right? And I have told you the well-known example, that is E is the vector quantity which is equal to minus the gradient of V. Okay, so this is a scalar function. Okay, so it happens like this, right? Suppose this is some operator, okay, and here this is a gradient operator, right? This is a gradient operator, and if you're applying the scalar function here, okay, scalar function, okay, so my handwriting is cursive one, right? That's why it is like happening like scalar function. So if you're going to input to this gradient operator, right, this is a gradient okay operator, so what does it output, right? What does it give you as an output? It will give you the vector 1. This is what you have to keep in mind. Okay, right. So from the total differentiation you can write dou v equal to what? Dou v can be written as dou v by dou x dx, dou v by dou by d by, from the total differentiation, dou v by dou z dz, right? Okay, the total differentiation, right? We know if you are good at maths, so you know all these things, right? Dou v by dou x dx. Okay, so here what you can do here is that dou v equal to what? This can be written like dou v by dou x ax cap plus dou v by dou by a y cap plus dou v by dou z az cap, right? This is one vector. Now there is a dot product, right? There is a dot product with another vector, right? And that vector will be what? That vector we are going to take is the differential length, that is dx ax cap, dy ay cap, and dz az cap, right? So if you will take the dot product of these two vectors, okay, so you will get this, okay, get back, okay, the moment you will multiply these two, right? Or you can say dot product, okay. So you know that dot product, there are two brothers, right? Dot product and the cross product. What is dot product? So ax cap dot ax cap will give you 1, right? A by cap will be giving you 1. Az cap, if unit vectors are same, you'll get 1. And as we know that x and y and z, all coordinate system we discuss, and we know that x, y and z are orthogonal to each other, right? As x, y, z are orthogonal, okay, to each other. So if you take the dot product with different ax dot ay, so it is going to be 0. Ay dot az, it is going to be 0. Okay, ay cap dot az cap. Okay, so why? Because they are orthogonal to each other. So cos 90 is going to be 0. Understand? In this case, cos 0 is 1. Please keep this in mind, why they are becoming 0. Understand? So this dv can be written as, this is what, this is del v, right? This is del v and this is dl vector, right? Del v and dl vector, okay? Del v and dl vector, okay? Del v and dl vector, you can say. So, or you can say gradient of that, right? So dou v equal to gradient is there, g vector, right? Or dl vector. So now what you can do here is that you can take the magnitude of this magnitude, okay, dl magnitude, right? And this can be written as cos theta, because as we know that a vector dot b vector can be written as the magnitude of a, the magnitude of b cos theta. Now it depends upon theta, okay? It depends upon theta. If theta is 0, right? In case if theta is gonna be 0, okay? So your dou b by dou l, you can take this guy here. Your dou b by dou l, maximum you will get. Maximum, that is gonna be your magnitude of the gradient. So gradient magnitude here, as I said that gradient magnitude represents, okay, so we are supposed to conduct a few mock exams as well, so you will get ample amount of questions, ample number of questions where you can test your knowledge, right, on electromagnetics. So if you will be able to solve questions from our mock test, so definitely it will be a booster, it will boost your confidence, okay, to smash HAL examination. So gradient magnitude represents maximum space rate, maximum space rate, right, of scalar, okay, in magnitude as well as in direction, right? Okay, so please keep this in mind. So this is what I wanted to discuss about gradient operator, right? So I hope gradient is clear now. And let us pick up few questions, right? Because after discussion of concept, we need to solve few questions. So the value of magnitude of gradient, right? The value of magnitude of gradient, okay. What we have to find? We have to find the value of magnitude of gradient at a point, okay, at a point 1, 5, minus 2, 1, 5, minus 2, okay, right, where they have given some scalar function as Vx by z, right, Vx by z, okay, which is equal to x square y plus e to the power z, right? Okay, so you have got vector scalar function and you have to find the magnitude of that, right? So what you can do here is that you can find del v, right? Del v will be equal to what? Del v will be equal to differentiate this, okay? So you have to differentiate this guy with respect to x first. So let us differentiate this with respect to x. So it will be 2x, okay, 2x, okay, by ax cap, right? Let me raise again and write properly. This will give you 2x by ax cap, because this az will be 0, and then by so x square only will be there, a by cap, because this x square will be have like a constant, and then it will be 0 and it will be e raised to power z only, right, in the z direction. So this is what you have got the gradient of. Okay, now what you have to do here is you have to keep compute this gradient at 0.15 minus 2. So this is going to be your 5 into 10, that is 10 ax cap, and this is going to be your a plus a by cap, right, and then plus e raised to power minus 2 az cap, right. Now what you have to find here, you have to find the magnitude of this guy. So the magnitude of this guy will be what? The gradient of v equal to under root 10 square plus 1 square plus e raised to power minus 2 whole square. So the answer, if you will compute, here, you'll get here as 10.05. And this is your answer. I hope this is clear. Okay, if you know the concept, you can solve the question. So let us take question number 2 here. The value of magnitude of gradient, again you have to compute, right? Or question is framed differently this time. Okay, that was the first question what we discussed, that was value you calculated. Now the question will be asked like, what is the magnitude of directional derivative? Okay, what is the magnitude of directional derivative? What is the magnitude of directional derivative of fxy is equal to xy upon under root 2, okay, x cap plus y cap, you can say, at, okay, at, or you can forget about this cap here, right? X plus y, you can write x plus y. This is xy, okay, x plus y. This is just a scalar function given, okay, so there should not be unit vector involved. So at p equal to p at p11, right? So what you can compute here is that you can compute del f, right? So the moment they will ask the magnitude of the directional derivative, so you have to compute first this is a two-step process, right? The first you have to compute this guy, that is gradient of f. So what is gradient of f? You have to differentiate with respect to x, okay, initially, right? So let us differentiate this, okay. So what you will get here is that you will get here is by root 2 x plus y plus. So let me differentiate this with respect to x. So you'll get here by root 2 x plus y plus, now with respect to okay, now differentiate this, okay. So you will get here is that if you will differentiate this with respect to x, so you will get 1 only, right? Because y will be 0, okay. So this will give you dxy upon root 2 ax cap plus, now okay, you will get x by root 2, okay, x plus y, again you will get x by root 2, okay, a by cap. What you can put here is that you can compute del f at 1 1, right, at this point. So this will give you what? 1, this is 2 by root 2, right? So you can say root 2 plus 1 by root 2 ax cap. Okay, so many aspirant make mistake here by with partial derivatives calculation, right? So don't make mistake while doing partial derivative. Okay, so this is root 2 plus 1 by root 2 after substituting 1 and 1, right? This is root 2 plus 1 by root 2, and this is a by cap. Okay, so now you have got this, right? So what you can compute here is that magnitude of the direction derivative, okay. So you can compute the magnitude of this guy. So once you will compute this, so you will get here is that you'll get 9 by 2 plus 9 by 2. So you will get 18 by 2, then you will get 3 as the answer. So please, after all, gradient of The magnitude of the gradient is also known as the maximum magnitude of the directional derivative. Okay. Right. So I hope it is clear for everyone. Please solve properly. Okay. Right. So let me take one more problem which was asked in GATE exam only. Right. So the problem says here is that, okay, if this time they have given the electric field, right? I did not talk about electric field, but I have told you this expression. E vector is equal to what? After all, electric field is a vector quantity and the gradient of this, right? So if electric field is equal to minus 2 by cube, 2 by cube minus 3 by z square, right? Ax cap, okay, plus minus 6x by square minus 3x z square, right, by cap plus 6x by z cap. Okay, so if this is the electric field given, okay, so what question they are asking is the electric field, they have told you that is the electric field, okay, they have told that electric field is this, okay, in a source free region, in a source free region. So forget about this what is source free region and all if you do not know, or already this is just a revision classes, so you might be familiar with source free region, right? Then the valid expression for electrostatic potential they are asking, right? Then the valid, okay, the valid expression for electrostatic potential, right, they are asking. So if E is given, that is 2 by q plus minus this and that, okay, is the electric field in a source free region where the source, what is the source of electric field? Charge, right? We have to consider there is no charge. So what are the options given? So they have given you the options, A option, the B option, the C option, and the D option. So in the options they have given electrostatic potential, right? So they have given here that x by cube minus by z square, right? And they have given 2x by cube minus x by z square and by cube plus x by z square and 2x by cube, okay, minus 3 by z, okay, 3 z square x, right, 3z square x. So they have given this electrostatic potential in the options. So how can you solve this question, right? So to solve this question, you will have to go from option to question, right? Okay, otherwise you will take much time to solve this question. Always be ready, in fact in GATE 2022, okay, many question was there where you need to go from option to question, right? You need to plug many values from the option to the question and verify and get the answer, right? So to solve this question, use E equal to what? E equal to minus gradient of V. So what you have to do here is you can compute the gradient of each options, right? Gradient of negative gradient of V. So you will get E, the given E, right? So once you will compute for all these four options, you will get option D as a correct answer, right? Option D. So you can try this. This option is gonna be correct, okay? This option 2xy cube minus 3yz square, okay? I hope this is clear for everyone, right? So let me talk about different operators. We discussed about Dell operator, right? That was gradient one, and followed by few problem we solved. Okay. Now we will talk about divergence. Divergence operator. So just unlike when we operate, the gradient operator operates on a scalar, it gives you the vector here, right? But in case of I mean, in case of divergence as well, when divergence operates on any vector, it will not operate on scalar, remember. Divergence will operate on the vector, right? So this will operate on vector, right? So we write it like divergence of dot, there should be dot, because del dot vector, some vector will be there, okay? So it will give you the scalar one. Okay, divergence operator, right? So divergence, the moment you take divergence of any scalar A, it gives you the scalar one, right? Scalar quantity. Divergence of A vector will give you scalar. How divergence is defined? So you can write here, the divergence is defined like this. The divergence of A is defined like the net outward flux. Net outward flux, that is A dot ds, right? And when we try to make this differential volume, right? Okay, when the volume is made to zero, right? When the volume is made to zero, so whatever flux you are getting, right? Net outward flux, okay? That is going to be the divergence. That is going to be the divergence, okay? So when the volume is made to zero, okay, and you are getting the net outward flux, so you can write here, the divergence is the net outward flux. Divergence, just I'm writing for you, okay? Black. Divergence is the net outward flux, the net outward flux, okay? Emanating per unit volume, right? Emanating per unit volume. So if you will be able to understand these concepts, so Gauss law and all, in case of Gauss law, divergence theorem we will use, right? So you will understand all those concepts, right? So the flux and all will come across there. So divergence is the net outward flux emanating per unit volume, where the volume sinks to a point, okay, where or volume is made to zero, you can say volume, where volume shrinks to a point. Shrinks to a point, right? Okay. So divergence is the net outward flux emanating per unit volume, where the volume shrinks to a point. Okay. It is nothing but the net outward flux of a vector A. Okay. So it is nothing but net outward flux. It is nothing but net outward flux of vector A. Okay. Right. So this is definition. Suppose there is a point, okay, there is a point charge, is, you will see that there is a point charge, okay. So if this point charge is plus, right, if this point charge is plus, so it will emanate electric field lines like this, okay. It will emanate, okay, there will be divergence, and the divergence is going to be positive, okay. Remember these things, okay. So if there is a positive sign like this, so this will be the flux going outward. So divergence of, you can say D will be positive, okay. And if there is a negative one, so you can say that there will be a negative divergence, because this kind of a scenario will be there, right? Flux line will be terminating at this point, right? So the divergence of D will be equal to negative. And suppose there is a flux line like this, okay, and there is a point, right? There is a point charge. Okay, so whatever flux line is coming, they are also outgoing, right? So there is no divergence. So we can say divergence is zero. This is a special case. If there is a divergence zero, okay. Right. So let us talk about divergence expressions in all three coordinate systems, right? So the divergence expression in all three coordinate system, divergence in cart, cylinder, and spherical. Okay, right. Divergence in cart, cylinder, and spherical. So divergence of V in Cartesian coordinate system, you can say, or divergence of A, just take it divergence of A, because V was uh, confined to electrostatic potential. So divergence of A, okay, this is a dot, okay, then it is read as divergence of A, right? So divergence of A will be what? Can write dou by 2x ax cap, right? Plus dou by a by cap plus dou by dou z az cap dot product with a vector. What is a vector? Ax component along ax cap, a by component by cap, az component az cap. Take the dot product, so you will get dou ax. Simply what you have to do here is you have to take the component and partially differentiate. Take the partial derivative with respect to x. Okay, take the by component. Okay, whenever you want to compute the divergence of any vector A. Okay, so this is how we do. We take the component of x, component of y, component of z, and perform the partial derivative onto it, right? So this is how we keep in mind, okay, for the examination as well. Okay, so this is the divergence, one of the elegant formula, right, or elegant expression, okay, partial first order partial differential equation, right, involved here, okay, in Cartesian coordinate system. So if I talk about differential, again you can see here there is a length involved. dou x, dou y, dou z. So these are the differential length. They are very, very important. Understand? So differential operator or differential expression in okay, the divergence in what? In cylindrical coordinate system. Now we will discuss. Divergence in cylindrical coordinate system. Okay. Divergence in cylindrical coordinate system. So divergence of a vector, right? A vector will be what? Divergence of a vector, right? So what we can do here is that we need to write here is like you have to take rho, component, multiply with rho, and take the take the derivative with respect to rho and divide 1 by rho. Remember what you have to do here is, it is a two-step process you have to keep in mind. First take a rho component, multiply with rho, and take the differentiation partial derivative of that component with respect to rho and divide 1 by rho. Understand? Plus dou y by dou phi a phi and simply 1 by d rho. Why? Because there should be rho d phi. Okay, there should be rho d phi. Understand? Rho d phi should be there. See, in case of rho component, what you have to do? Take rho component, okay, and multiply with rho and take the partial derivative and then divide it. So in this manner you can keep in mind forever, right? Forever. So 1 by rho dou by dou phi a phi, okay, this is a differential length here, and z is simple 1 by az, okay, component. So this is very easy, right? So you don't have to you don't have to mug up or memorize anything, right? You can put in the short note, right? Let me write in the next slide again. Okay, so here keep this okay in mind how I'm writing. So without any remembrance, or you need not to remember or recall or what, just keep this in mind. Suppose aero component is given, a phi component is given, az component is given. These component will be given, right? Whenever you want to find mm, the divergence of any vector quantity, any vector field, okay? So what you have to do here is just pick up this a rho component, and multiply. Okay, so let me take a rho component here and multiply with the rho. Okay, so keep in bracket so that there will not be any confusion, and partial derivative with respect to rho divided with 1 by rho. Understand? Plus what you have to do now, you have to take this component phi component, so write a phi, okay, and take the partial derivative with respect to phi, and this should be there rho d phi, and okay, plus take z component and take the partial derivative, right? So this is how we write. Okay, so if you will go into the detail, there are various concepts, right? It is given in fact in Hayat. Okay, so but for the time being you need to only know this expression, so don't get inside how these expressions, okay, come about and all. But please, okay, in our classroom program we discuss all those things as well, right? Okay, for the gate examination, for HAL this is enough. Okay, so divergence in case of spherical, how we exactly, remember or keep in mind, the format. So what you have to do here is you will be given AR, A theta and A phi component, right? These component will be given, right? Okay, so pick up one component at a time. Okay, just pick up this component. What? AR component. Take AR component. Okay, this I have taken. Now what you have to do? You have to multiply with R square. Okay, take take R component and multiply with R square and take the partial derivative with respect to R, and whatever you have multiplied with that component, divide it. This is simple, right? This is simple. The first term plus phi, a theta component is there, right? Theta component is there. So what you have to do here is you have to take a theta, multiply with sine theta, right? Take a theta component, multiply with sine theta, keep the bracket, and d theta, and whatever multiplication you have done with the component, right? Just divide it 1 by sine theta. It is very easy, right? Sorry, there should be r sine theta because r d theta will be already present, right? So it should be r sine theta d theta plus 1 by r sine theta. We don't have to multiply with anything in the phi component and just write r theta time r sine theta d phi. It is very easy to write. Okay, so can we repeat the same quickly? Please see how I'm writing, so you can also write in the future for the exam, right? You can recall. So you can see here the divergence of A in a spherical coordinate system can be written as r squared dot ar, just multiply and differentiate it with respect to r and divide by r square plus differentiate it with you know theta, multiply with sine theta a theta, okay, and divide with r sine theta, okay, plus 1 by r sine theta dou by a phi dou phi. So this is how we keep everything in mind. Okay, so please keep this in mind. How I'm using it, remember, this is r component and multiply with r square and divide. Okay, this and this. So this and this is, you have to divide with sine theta. So this is how we keep in mind for the examination sake the differential operator as well. Let us take one question. The question here says that, what question says here is that the direction of a vector, right? The direction of a vector, the direction, this is a gate problem again, gate problem, I think gate 2011. The direction of a vector is radially outward, right? Is radially outward from origin, okay, with they have given the component here, that is magnitude of a is given k r to the power n, right? So they have given a r component, right? Because r is there, k times r to the power n, and where they have given r square is what? R square is basically x square plus y square plus z square. We know as well, right? Okay, this we know. Where k is constant, okay, where k they have told, where k is constant, this guy is constant, right? The direction of a is radially outward from the origin with a equal to k r to the power n. Okay, so what is the value of n? Now the question is then what is the value of n, what is the value of n for which the divergence of A is going to be 0. What is the value of n for which divergence of A is going to be 0? Remember, so they have already told you that the divergence is going to be 0. So see, by looking at r square equal to x square plus y square plus z square, don't go and use the divergence expression in case of Cartesian coordinate system. It will be quite difficult, right? Because they have given you have to identify what is given. This is the r component, right? Remember, they have given r component. Okay, the magnitude of something is the component basically, right? Okay, component of r, which is given as a times r to the power n. You can say ar. What you have to do here is divergence of a, and rest of the components are 0, so don't write. So what is the uh, divergence formula for spherical coordinate system? So divergence formula for a spherical coordinate system means you have to multiply this with r square, right? So multiply r square times k times of r to the power n. Okay, just put bracket, differentiate it with respect to r, and divide it with 1 by r square. Okay, and rest will be 0. Rest will be 0. Okay. Now what you can do here is that 1 by r square, don't cancel this, right, unless you differentiate. So just perform the partial derivative onto okay, so dou by dou r, and this will be k times of r to the power n plus 2. Okay, now you can take common k r square, and this will be n plus 2. Okay, n plus 2 r to the power n plus 1, right? Okay, this is n plus 2 minus 1, this is n plus 1, right? So when this will be equal to 0, when this will be equal to, when n plus 2 is gonna be 0. Okay, okay, r and all cannot be equal to 0, right? R cannot be equal to 0, remember. So this guy, okay, this guy n plus 2 will be equal to 0, right? So keep this in mind. So n here, the value of n will be equal to 2 for divergence A equal to 0. Understand? So answer will be minus 2, not n equal to 2. Please keep this in mind because n plus 2 is given. Na? So you have to say that n equal to minus 2 will be the answer for this question. Okay. So I hope this is clear for everyone. Right. So let's talk about Laplacian operator as well, the very important operator. Then we will discuss about Laplacian operator. Laplacian operator. So what is Laplacian operator is basically for the scalar. Laplacian operator exists for scalar and vector both, right? So for scalar, we will particularly discuss. So the Laplacian operator is basically del square on scalar, right? So del square V is known as the Laplace. Del square is basically the Laplacian operator. So del square V can be written as the divergence of the gradient of scalar C. Divergence can be operated on what? The vector one, right? And this gradient can be operated on what? The scalar one. Once the gradient will operate on a scalar, it will make you the vector, and that will make the vector, then you can operate, divergence operator as well, right? So del square V can be read as, okay, can be read as what? This can be read as divergence of grad of V. Divergence of grad of V. Understand? So please keep this in mind. This is the Laplacian operator. Divergence of gradient of scalar, or you can say divergence of gradient of scalar. Okay. Okay, so Laplacian operator of any potential scalar, okay, which will be proportional to the flux, okay, in future you will find. So if I write here if I, in future we'll talk about curl as well. So the curl operator, we will discuss here what is curl basically, right? So let me discuss about curl, right? What is curl? So curl is basically again will be operated on vector, and it will give you the vector only, okay? It will give you the vector, right? So curl of a vector, right? Curl of a vector, curl of a vector, okay? Curl of a vector, curl of a vector is operated for a vector, and result is also a vector, right? Is operated for a vector, and result is also a vector, okay? Keep this in mind. So once the curl is operated for a vector on a vector, you can say, and result is also vector, right? Curl is determined by using right hand rule, right? Curl is determined with the help of, so it represents basically the rotation, right? The curl will represent the rotation. If there is no rotation, means curl is 0. Okay, there is a rotation like this. Okay, so the curl is basically represents the rotation, and right hand rule we have to use. So the definition of curl in Cartesian is curl of A is written as here with the help of matrix. Actually, you can find out the curl, right? With the help of matrix. What you have to do here is you have to put inside this matrix what? So here AX component, A by component, AZ component, right? And here the partial derivatives do X, do by, and do Z. And here components AX, A by, AZ. So element of a matrix, sorry, element of a determinant. Okay, this here determinant kind of, right? So you have to compute this determinant AX, A by AZ, right? And in case of this is in case of Cartesian, right? Now in case of cylindrical, what will happen is you have to be very careful. So the element of this determinant will be what? Use the determinant concept, okay, to compute curl. So a row cap, row a phi. Here you have to keep in mind row you have to keep, okay, and a z cap. Do by do row, do by do phi, do by do z. Here a row cap, sorry, a row component, row a phi. Definitely you have to keep row and az, remember. And outside also you have to keep row. So only three important points are there which you have to be slightly focused. You don't have to forget one by row factor here. You don't have to forget this row, and you don't have to forget this row, right? That's it. This is in cylindrical. Okay. And in case of spherical, again, please keep this in mind, this determinant. So AR, uh, AR cap, and R A theta cap, R sine theta, A phi cap, right? And here the partial derivative. derivatives, and here the component component, r component, r sine theta, a phi component. Okay, and outside you don't have to forget 1 by r square sine theta. 1 by r square sine theta. Or 1 by r square sine theta. So the point of caution is what? You have to keep this factor, you know, these are this r sine theta, r sine theta, that's okay. So this is important. And you just take one question and stick question and realize the curl. Okay, so if a vector is given, suppose if a vector is given, a is given, right? If this guy is given, a vector is given like cos x sine by a x cap plus sine x cos y a by cap. Okay, then what is the magnitude of the curl of a? Then what is the magnitude of curl of a? Then what is the magnitude of curl of a? So what you can do here is that you can just write here ax cap a by cap az cap, right? And just write the component. I mean, just do x, do y, and do z, right? And right here the cos x sine by cos x sine by sin x cos y and 0. So the moment you will find the determinant of this, right? So you will get 0, right? So just you can take, so just first just you will multiply the, I mean differentiate this, and there is no z term, right? So it will be 0. So overall the curl will be 0, right? So this is how we compute the curl and everything. Okay, so if I talk about various types of fields, right? If divergence is 0, then that is known as solenoidal fields. If the curl of a vector is 0, that is known as conservative. This kind of questions are very, very important in the gate, in IES, in any PSU examination, right? Some vector will be given, they will ask you curl of a vector is 0, so and what kind of field it is, right? So the various kind of fields, okay, various types of field, right? Various types of field. Number one is solenoidal field. Solenoidal fields, which is divergence of any vector equal to 0 is known as the solenoidal field, right? Conservative field, or irrotational field or harmonic field. So irrotational means what? The curl of any vector, if it is 0, right? So that is known as conservative or irrotational fluid. Understand? And solenoidal means what? The Laplacian is going to be 0, right? So we'll see all these things, right? So Laplacian is that del square V, if it is equal to 0, that is how. So this is in brief, you have to keep this in mind. So if I talk about one by one, that is solenoidal. That is divergence of A vector equal to 0. How it is read? Divergence of something is 0, right? That is solenoidal, right? So this does not have any source or sink. If the divergence is 0, what does it mean? What is the physical significance of that? What is the physical significance of that? The physical significance is that the water is coming and it is not collecting anywhere. It is flowing, right? The flowing water does not have any divergence. See here. The flux is coming and flux is going, okay? So the divergence is 0 means it does not, okay? So it does not have, it does not have any source or sink, any source or sink. It does not have any source of sink, source or sink you can. Source or okay. And always form a closed loop. And always form a closed loop. Always form a closed loop. It does not have any source or sink, right? Or sink, and always form a closed loop, right? So the best example what we can do now, okay? So you might have seen in the magnet there will be the magnetic flux, right? The magnetic field, okay? So from N to S, okay, it is always forming a closed loop. It does not have any source or sink, right? Like unlike charges, charges originates from the positive charge, flux line originate from the positive charge and it terminates at negative charges, okay? But in case of magnet, in case of magnetic field, the magnetic flux line originate from the north and it does not terminate at south, okay? It enters from the south and it forms a closed path, right? A closed path, right? So divergence is going to be 0 there. So the best example which I'm giving you, best example which you have to keep in mind always, that the divergence of the magnetic field intensity, okay, divergence of magnetic field is equal to 0 always, you can say. What? Always. What does it mean? What is the meaning of this? Divergence of B equal to 0. What does it mean? It means that the monopole does not exist. Monopole does not exist. Okay, the best example is what? The monopole does not exist, right? Monopole does not exist, okay? So if suppose this is a north and this is south, and if you will cut, again you will get north and south. So your magnetic flux lines will be always, will be forming a closed path. So keep in mind that the divergence of B, magnetic field, okay, magnetic flux density you can say, or magnetic field, sometimes it is also regarded as magnetic field, okay, equal to 0 always, okay? This is the best example of, this is the best example of what? This is the best example of divergence of V. Best example of solenoidal. Right. Now let's talk about conservative field. So as I said that the conservative field or irrotational field, right? What does it mean? The curl of a vector is equal to 0. Curl of a vector is equal to 0, right? It is also known as the vortex field, right? It is also known as the vortex field, right? It is a path independent, okay? It is what conservative field means that it is path independent. Remember, conservative means it is a path independent. It shows the independence of path, right? It is path independent. Okay. All right. So we will study in future that regarding Stokes theorem, where we will compute a dot dl, the line integral a dot dl, right? So there you will find that if the curl is equal to 0, okay, if curl of a vector is equal to 0, it means that a dot dl will be equal to 0. It implies, okay, so remember this. So if conservative fields can always be represented by the gradient of a scalar, remember, any conservative field, note, you can note here, any conservative field okay, any conservative field can always, okay, in the gate 20222, right? One question was there, and you apply like you have to find first the divergence of that, and divergence was coming out to be 0, so answer was completely 0, right? So it was very easy question, right? So if you know this concept, definitely you can ace an exam. So conservative field can always be represented by gradient of a scalar, represented by gradient of a scalar. Okay, conservative field can always be represented by gradient of a scalar. It means that if the curl of a vector E is equal to 0, that is conservative field, it means that the E equal to, you can replace it by curl of, the gradient of V, right? So it implies that the curl of a gradient is always 0, right? Remember, the curl of gradient, if somebody will ask, so that is going to be 0. Curl of a gradient is always 0. Curl of a gradient is always 0. And the harmonic field, in case of harmonic field, guys, in case of harmonic field, okay, as I said that the Laplacian is equal to 0. Okay, so let us take one question and realize the concepts, right? Whenever we discuss any, okay, so I'm not going into deep, I'm just discussing in brief, okay. So remember, this is the revision, okay, this is the learning theory and the questions, okay, followed by the question for HAL examination. Exclusively these sessions are being conducted, okay. So we are not going more into detail, but I'm telling you the detailed thing only, whatever we discuss in our regular classes. So what is the value of B? What is value of B? So that, what is the value of B so that A vector is equal to, A vector is equal to bracket x plus 3y ax cap plus bracket by minus 3 ay cap plus x plus bz az cap, right, is solenoidal, is solenoidal. Okay, so this is one of the gate question only, and it is very easy, right? They have mentioned that this field is solenoidal. So what does it mean? It means that the divergence of A is equal to 0. And you have to find the B, and B is present here. So divergence of A is equal to 0 means take this component and differentiate it with x to 1 you will get, because this is by and this is 1 and this is B equal to 0. So B is going to be minus 2. Okay, so it is very, very easy, right? And in the next question, this kind of questions are always asked in GATE. Though in the GATE 2022, many question was not there, but if you go back in the GATE, so definitely you will find various questions. Okay, but applications are always, right? So nowadays the patterns are different, right, in the GATE and HAL and everywhere. So please make sure that, but in HAL question will be expected, right? They will not surprise you. What is the value of A, B, and C? What are the value of A, B, and C? Show that the V vector is equal to x plus 2 by plus AZ, okay, AX cap plus 6x minus 3 by minus Z A by cap, okay, plus 4x plus C by plus 2Z, sorry, AZ cap is irrotational, right? Okay, so irrotational, 1R, you have to forget this, 1R. So where is A here? A is here, right? And there is a B. Please, this is B, not 6. This is B, right? So now what do you have to do? Irrotational means what? Irrotational means conservative. Conservative means the curl of the V vector is going to be 0. So just write the determinant, write the determinant, get the A and B and C, everything, right? What you have to do here is that just write like this: AX cap, A by cap, and AZ cap, and write the differentiation here, partial dou by dou x, dou z, and components. So x plus 2 by plus az, bx minus 3y minus z, Okay, and here 4x plus cy plus 2z. Okay, and once you will put it equal to 0, so you will solve here, right? So what you will get here is that ax cap c plus 1 a by cap 4 minus a plus az cap b minus 2. Once you will solve the determinant, so from here c equal to minus 1 and b equal to 2 and a equal to 4 you will get, right? So this is going to be your answer, right? Okay, so this is what I want to discuss for today. And in the next class, we will talk about various types of integrals, line integral, surface and volume. And we will talk about Stokes theorem, divergence theorem, and Gauss divergence theorem, right? And then we will go to electrostatic, okay? So in the next class lecture, okay, very important lecture, right? Because every year, in fact, in 2022 as well, question was there from integrals, right? So please make sure to attend. Thank you so much for today's class. Okay, so you can watch these sessions on YouTube as well, and do comment on YouTube, right? If you have any doubt, okay, you can reach to us. Thank you.